Okay, so we're gonna go over unit 2 or week 2 materials. Um, get captions on and then we'll share screen. So make sure we download the notes and the assignments. This. Let's zoom in. So in this week, we're going to go over software application management strategies and implementing security solutions with software development and software applications. Um, so we'll focus a lot more on, building, development, security, and then a little bit of integration in the organization. So with that, we're going to go through and answer some questions. So at the beginning of the chapter, it talks about, let me switch back to notes. It talks about software development life cycle, and you're going to see this throughout some of the upper classes for the security, because ultimately, this is a very important area, right? If we design the application with security in mind, I think we're going to run into less of an issue when we deploy the application. So in development, we want to look at the software development life cycle, the stages that it goes through from the beginning to the end, right? So your SDLC life cycle. I forgot the C there. But so with that, we would look at the processes and the steps and how we can integrate some security practices in software development lifecycle. Okay. Okay. So in the first question, it asks you, when developing software, what should organization consider? Right. When we start building the software, we have to think about the objectives of our software, right? All software is designed to solve a problem. It's utilizing the hardware to be able to compute. So we want to look at the legal requirements for our software. If it's a web applications, right? The goal of the software, what is it doing, and whether there's some legal obligations that we have to fulfill, especially with data privacy. That's a big thing right now, right? If there are compliance requirement where we have to use encryption, or connectivity requirement and so on, right? So legal requirements is important, and that can get integrated into the technical design of the application. And then we want to scale. So scalability is important. Let's say that I'm designing the software to release on the smaller scale, but I ended up utilizing it. There's more demand for my software. So we want to be able to scale, to grow for, with data management, and also how it's integrated or deployed with the organization. And most importantly, and this is why we're looking at this, is the security needs, right? So protecting the data, protecting the user information, if you're using sensitive information with the software, like social security number, personal identifiable information, it's important to kind of think about that when we are developing software. So the key activities and the components in the first stage of your SDLC would be identifying your system goals, right? What are you trying to do with the software? And if you have users that are using the software, you want to obtain their expectations and requirements. So let's say it's a financial application. We want to talk to that particular user group. We interview them and we want to find out what they're expecting the software to do. What is the final product? Right? So if my financial software is going to give me some form of report, maybe ask them, like how the format of the report, what do they prefer, right? So we look at the needs and then the desire from the user. And then some features and tools that they might need, right? So we might need a reporting tool. We might need some kind of analysis tool in our financial software. So expectations and requirements is important in the initial stage of your SDLC. And we would identify the project resources. That's going to be the work hours or the development hours that's going to be put in, money, time, right? And we say man hours, but it's work hours that we would put in for design and development. So the resources that's required for this particular development project. And if we have to consider alternative solutions for that particular application, right? So that will be discussed before we go into design development. And for most organization in an enterprise level or a large scale level, you would see system feasibility study. So they would do comparisons, analysis to see if it is feasible to implement this particular software, to go through development and deployment for that software, right? Like, let's say the organization is retiring a legacy software, and you see that all the time. So before they phase it out, they have to think about the replacement software. So feasibility study is going to give us an understanding of whether that software is adequate, right? That solution is adequate for the organization. So in your notes, it gives you the image, right? So we're talking about this in the first stage. And then after you have that, that's going to give you the planning for your development. So that's going to lead to the second phase, which is development. And in here, we would design our software code, right? And then after that, we would go through implementation. So you can see all of the detailed information listed on the note pages here. Now, the security considerations, I had listed it here. We have to think about security constraints, connectivity, because that will, that can eventually expose data or impose some kind of risk, and then compliance requirement. So when we're dealing with credit card information, sensitive information from the user, the consumer, or our customer, that can also be essential. So we have to discuss that in the initial stage. So in the development stage, this is where we would outline some of the features on how we would be able to build it, looking at alternative designs, right? Because, we want to make sure that it is suitable for the user and meet their expectations. And then we want to create system design documents. So when I teach programming classes, especially for computer science students, we emphasize this a lot, right? You should document as you go, and when you modify your design, you should document it. So that way, when you have an output, you have a reference point. So in the future, when you're doing updates to your software, you would go back and looking at the features through the documentation, right? We don't want to go through and recode everything. We want to go through and look at the section that we need to improve or fix. So in this area, we need to do risk assessment. That means that we need to do static code analysis. And I pulled some of this from outside of the book from a professional industry website. So you got the static code analysis and you got the dynamic code analysis. So basically, these are tools that allows you to go through the source code, possibly line by line, to look at vulnerability features. So I was curious, and today I had a moment and I just used AI and I asked AI to write me a script for SAST, and it did it. And it's actually short and sweet. And I looked at the script because it's already integrating some of the existing library. So you can definitely write a script and automate it. So as we write the code, let's say in Python, we can have it tested, right, to see if it's meeting the security standards. Okay, so we want to look for things that is it susceptible to attack, right? Like SQL injection, if you're using database, like an application for database, if it's web app, right? You have considerations in security. So in static code, in your static application security testing, your SAST, your book didn't really define this well. So this is the resource from the internet. Once we compile the code, so when we're looking at C++ or Java, that needs a compiler. So objective-based language, once we compile the code, right, we would put it through testing and it would be static. And so there are some of the steps on how you would look at. So it depends on, you know, how the language and the program. And so once we test it, we can go through for deployment. Some tools would have customization. Other tools would just be a scanner. But you want to make sure that you track your results. So we're going to do some of this today. Right? The output from the scan, right? And you want to take a look at the issue that you have, go back to development and then fix it. Right? And then test it again. Okay? Anytime that you make changes, so you have to go through change management as you do this. So as we improve the application through development, reducing security risk, we want to make sure that we track our changes. Okay, so we need to take a look at the scan results. So as an analyst in security, if you work in this area, application assessment, you have to utilize the static and the dynamic application testing tool. Okay, and then comparing it back and seeing how, you know, your test result, is that going to be adequate for the software to move forward and eventually get integrated into your organization. The dynamic application security testing, this is ideal for web application and it's ideal for front end. All right. So we use DAST to look at application vulnerability, very similar to SAST. And we want to see if it potentially could it be attacked, and what is the expectation when we find a vulnerability. Of course, we want to mitigate it, right? To see if there's a way that we can redevelop or fix that problem. So we have to coordinate, and some of this can be automated, but sometimes, you know, so here is an example that the book provided. You got web app 1 compared to web app 2, right? And so for the design team, we want to look at the area that we test. So test encryption method that's used. We can test data input, and the best testing in security for data input, you guys know which tool we use? Fuzz. Okay. So basically it performs an attack in sometime brute force username and password to see if that potentially it could be attacked. Fuzzing tool.
Doing it.
Yeah. On DVWA. On the damn vulnerable web app. So yeah, we are doing that today. Okay, so in our assignment, we can go through and answer the next question. So for question 3, it says, in development stage for SDLC, what are some security practices that the organization should incorporate? So in the development stage, we talk about analyzing the risk of our software. And with that, from a security professional standpoint, we would need to perform pen testing. right? And some organization would refer to this as stress testing, but basically we would try to identify the security gaps in that software. So that means that we will need to do static application security testing, your SAST, and or dynamic application security testing, DAST. And there are open source tools and proprietary tools. There are proprietary tools that are wonderful that have features and things that you can integrate or you can use for reporting and also tracking changes through your software for security improvement. And then there are open source tool that we can use. So today we're going to use an open source tool. And the tool that you select is also based on the language that you have that's used for development. So if I'm using PHP and JavaScript for web application, right, my tool has to be created for those languages. So you might find a cool tool, but it only works for Python or C, right? And you cannot use it for Java. So I recommend that if you work in this area, you would have a tool set, right? A group of tools that you would use for various applications. Web applications sometimes would have frameworks and then also web-based languages. So the tool sets that you're gonna have is gonna be diverse enough so that way you can assess a lot of different applications. So in an enterprise, you might have applications that are written in many different type of languages. Okay. Could be in JavaScript and so on. So if we have the adequate tool, that will be streamlined in our effort for assessment of software. Okay, any question on this? In the past, I think for my other classes, I've used Pilot before, right? We're gonna use something similar that's already incorporated with Kali Linux. We're gonna use Splint today, and Splint is for C, right? The difference between C and C++, you guys know? Huh? Difference between C and C++? Objective is one for C++ and the other one is not. So C doesn't use classes and C++ use class. Right? Python is a C-based language, right? It is in the family, but it is objective. So you can see that we would use classes in Python and the same thing with Java, right? So we're gonna test like a simple C program. I borrowed somebody's program for the lab today for the sake of it. But you can also, if you have your programs, you can run through the tests to see how it works. Okay. So after development, we're gonna go through implementation phase. And for security, the activities that we're gonna perform right in the implementation phase is going to be vulnerability assessment. Now in pen testing, we also do vulnerability assessment, but in implementation phase, we want to focus on, right, the weaknesses of the software. So for example, if your software is using third-party libraries that is not trusted, that is a weakness, right? So we want to look at the CVEs of the libraries, so common vulnerability and exposure. Or if we're implementing API, we will want to look at the vulnerability in the API we're using. No software is perfect, right? Or that software is using a certain type of services, right? Protocols that might impose some kind of weakness. So when you're looking at software, especially web-based application, you would see that it needs to have communication. So like the lack of encryption, things like that, right, is going to give us the vulnerability information that we need, and we need to make sure that we improve that software in the next version. we would assess the infrastructure. So that means that how that software is being released, right, and implemented into the organization. So it might be maintained through an application server for web application. It would be, through the web, um, or it could just be natively integrated onto the system or on the server itself, right? So the infrastructure really pertains to that particular application and, how it's set up, right, throughout our network for access. And then with web servers, how web servers is communicated for that particular application. And then some of that was tied to like authentication and other areas. So that list could be a lot longer. But in general, most application would have some kind of database. It would have some kind of web connection because the majority of our application is web application, right? Even Office 365 that you see, that's a form of web application now. Before it was a native application where you have a disk and you install it, or a download file and you install it, right? So a web application, it needs to communicate with the server, the web server, in order for it to run. Like when you play a game online, right? In order to pull the status of your game, it has to go fetch it from the database where it updates, right, your game information or status or points and so on. Any question? So here it talks about the implementation phase. It gives you a little bit more about, tracking the bug and fixes. You also have to train the user, and the consideration. So we talked about vulnerability here. And then we want to implement your SRM or your SRTM for security testing. So you have to continue to assess and test your application, right? And if we identify the flaws, we want to document it and then try to mitigate the vulnerability. So after it's going in deployment and being used, sometimes you have to refresh the hardware, like the computer, the server, the database server, and so on. Because over time, right, the system would be worn and it would, sometimes you would be maxing out in RAM and storage. And then we want to do performance benchmarking. So, and that's really telling us whether our software is to its best. Then we would patch. This is when we close out some of the security issues or software bugs. So we need to patch hardware and software, sometimes firmware. So if you're looking at applications for Internet of Things systems can be integrated in an enterprise, that could possibly be, right? So if you're looking at like FedEx, UPS, shipping company utilize, right, hand scanner to track packages when it's get delivered, right? Now it's kind of like a smartphone format where they can also take a picture or a tablet looking, so when you can sign. So with that, you need to update the actual device, and sometimes you have to update firmware along with hardware and software, right? So we have to consider the type of device that's being used and how, with that, the application that they use to, for you to sign your signature once you receive a package. It's an application, right? So once you sign and you click submit, your signature gets sent to their database, right? And it shows, and then they type in your last name that you received the package at this time. That gets update to the database, and then, so if I'm tracking that package, it would show, oh, it was delivered and it was received by this person, and here's the signature, right? So instantly you have the customer application that's able to track the package, but you also have the back end application where, you know, from the employee all the way back to the company or the corporation like FedEx, UPS, and so on. So we're going through the assignment. We're at number 4, going into number 5. So the security activities that would take place in the maintenance and operation, we talked about patching your hardware and software. And like I mentioned, sometimes could be firmware, right? Depending on how your application is used. Incorporate system and change management, because your application, it is part of change management, right? Because when you're integrating a new application, it is changed to the environment of your system. But when we're updating versions or upgrading versions, I should say, and then updating or patching, that's part of change management as well, right? Because you change the nature of the software and the hardware. And as you know, that sometimes updates can work negatively. So we have to roll back, and so we have to track the changes and making sure that we have viable or feasible options to make sure that our system continuously being used. So in the book, it talks about CI and CD, right? Continue development and continue integration. So in a corporate environment like enterprises, right? You're looking at like Walmart application online, where when I type in walmart.com, right, it lands on the page. I can order a product, I can locate a product, I can look at the price. And then some company like Walmart would also allow other sellers to sell on their website. So someone can also be part of, you know, utilizing a different component of the application to sell instead of Walmart just selling to its customer. So that means that in continuous development, it needs to be fluid enough where they continue to program and making sure that that application changes with the nature of, you know, the company, right? So let's say that one week Walmart might sell a certain product that is very popular, right? Or social media might market a certain product. So they have to continue to market that product so that way they can have the sales, right? And you see this with Amazon and all the retailer online. So, and then when I continue to develop, so it's kind of like building the plane as you fly it, right? But in this case, we build and test and then integrate at the same time. Okay, so we'll talk about some of the approaches as well. So we want to monitor the software performance, right? That's important because that's part of the A in CIA for security. So making sure that it's available, it's responsive. It's, you know, a lot of the times you have to look at the user end of the house, right? Is it easy to use? Is it responsive to the user? But overall, the software performance is important, and then any additional security needs. Because if it's prone to attack, like cross-site scripting, if it's web-based, right? SQL injection, and then, you know, with web, you got communication. So how we can template it and improve it and making sure that our software is safe. Because nobody wants, it's a reputation of the company as well. Nobody wants to use an application that's not safe. So when you're looking at a mobile app, right, through Google Play or Apple App Market, when someone publishes an app on there, they have to go through app testing, right? Microsoft App Store is the same. So if I'm a developer and I created a software, maybe a simple one, like something to calculate calories on a daily intake for someone, and someone can just download that, right? Take a picture of your food. It identifies, whatever that's in your on your plate or on your bowl, and then it calculates it, right? Or the user would input, I ate half of a pound of this, right? Like beef jerky, calculate my calories. So something like that would have to go through testing, and a lot of these technical company would require compliant testing and so on before your app gets published, right? I know Apple, and I don't know if Google charges now, but they require a membership for development, and then if you push your app on there, right? So it has to go through the testing. So not everybody can just publish an app. And if your app fail, right, you have to fix it, and it will tell you what to fix. So similarly, we have something like that in security, right? In development, from the development stage into the implementation, we have to make sure it's tested. And then for the last stage, when you dispose software or a system, you gotta make sure that your data is archived or purged accordingly, right? If it's sensitive data, we wanna make sure. So it goes back to compliant data retention. How long is the data is gonna stay there? So for an institution like RCCD, grades and attendance will not go away. So for someone who went to school, let's say 15 years ago, right? You never know, that person might come back to school again, right? So now if the education institution doesn't retain the data anymore, it gets sent to the Department of Education, like in the case where the school closed, or something happened to the school, or if it's older historical data that gets sent to the database with the Department of Education. Now in different industry, you have to house the data based on the regulation, the requirement. Okay. And then healthcare, they have a certain amount of time as well, because patient might come back with different diagnoses. So you have historical data that's going to help the doctor, right, determine the cost or, whatever that they need for the treatment. So when you purge the data, we're going to make sure that we wipe the data accordingly. And then we have to remove the data from all the sources for that system or the application. So database, right, storage, backup, all of those things. If we archive the data, right, we put it into archive format and we put it into the archive system. It is just a storage system that stores historical data, and in the archive format, sometimes depending on the software that you use, it would save space. So you have to unarchive it, you have to pull it down. Documents and things, you often see that they like to archive it in PDF because it can be read in a lot of different systems. Sometimes that, it depends on the software. It might convert it to its own file and then convert back to other format if needed. So disposable phase, you would see that on page 5. I know the chapter for these, the notes tend to be long because there's a lot of information on the higher level. So in the next few section, and if you took ethical hacking or other classes, I think I also talked about this in 41A. So these are models that the industry use. They are just approaches on how development projects can start and finish. Waterfall is traditional. You start, right? You build the software. So you gather the requirements, you design, and then you go through testing at the end, right? And if the customer doesn't like it or if the test failed, you start all over again, right? So you come back to the beginning. And this can be wasteful of resources. traditionally we've done this, but now, so here's like the step by step. So there's not a lot of changes can occur in the waterfall model. So if the customer come back and say, hey, when we get here, we got the final product and they're unhappy. They're like, oh, I want additional this and this. You got to go back over here, right? Put in that requirement and redesign. So it talks about advantages and the disadvantages of this particular model. You see a lot of job, right? If you're looking into like management or working with development, they talk about agile. This particular methodology is popular in development. This is what for the most part, most companies use this. It is easy to adjust the requirement. So that's why. And you do more like regular testing. So there's more customer involvement or more, so the user involvement. So whoever that's using your software, you would see some of that. So for question 7, it says, in the waterfall approach, when is the customer involved in the software development process? They're involved at the beginning and the end. In the requirement stage is when the customer tells the developers or the development team what they need. And then the development team will design and create the software, test the software, then bring in the customer to test the software. You guys see this also with beta? So at the end of the project, if the customer is happy, everything is good. Software is complete. But if the customer is not happy, we start from the beginning again. Add in the requirements, go through, right? And redesign. In the agile approach, the benefit of this is it's used for adaptive development. Like we mentioned before, right? We might have a web application that's adapted to trends. You see this with social media. Social media apps are really adaptive to its user. And then in the case where if the customer requests frequent changes or frequent updates of the software, Agile is good for continuous integration. Like I said, CD, CI, right? Continuous development and continuous integration. It goes hand in hand. So you're gonna have a lot of different versions in frequency, right? Like very regularly. Compared to, the other model where you would see once in a while, you would see a version that comes out. So this is a little bit more, you would see that the growth in the software, right, is better with the agile methodology. So the third methodology the book mentioned is your spiral development approach. So the question is, what is the primary component of the spiral development approach? How is this component used throughout the development project? So if you go through that section, it really talk about, so the main objective of spiral development is to prototype. And you would use that prototype, right, in the overall project. So we would refine that prototype throughout development project to get the best result for the final product. So it's slightly different than the agile approach. Now, the consideration of which methodology to use, it really comes down to resources also, right? Like we have to take a look at cost. So for a company that doesn't have the development team, or even when they outsource it, and then whether they have in-house or outsourced type of development, how much they need it, and so prioritizing the components of the software and so on. So when you look at all of these models, ultimately, you will have the later updates for the software. And the text or the notes talk about another method where we would integrate more of a version control environment. But we version control throughout these methodologies as well, right? So I try to teach my beginning programming students, especially in the discrete structure and the other classes for the computer science major, to use GitHub accordingly, and then making sure that they put down the version number for their software. So if they go through and modify it again, right? Because sometime I get a GitHub repository, just the project information, project name on it, that's it, right? So we should also standardize that process, right? In corporations, they would standardize that process in how they are managing versions, and then tying it back to the industry, how we would use a certain version number a certain way, like the format of the version and tracking that version. Because you might have new development team or new people that comes in and write your code, and that reference back to your older versions, documentations, and repository of your source code, that will be helpful. So after the agile, you would find the spiral, right? Here's the picture. So the objective of the project, then you need to look at the risk, and you would see different, kind of like what we talked about with version number, but you're gonna have different prototypes. So refining prototype 1, you're gonna get prototype 2, and then when you get the final product to the best, and that qualifies for use, then it becomes your operational prototype. So your drafts become your prototype versions. You still have to test it after integration. So in Spiral, you're gonna have a lot more collaboration with your team members. And it is flexible. It is expensive though, because the involvement of developers, that's gonna cost. And then the phases and the iteration, the repetitions, right? Takes more time, more resources, more manpower. There's versioning, and this is considered CI/CD, like I mentioned to you before. So to answer that next question, it asks you, why is version control important in software development? Ultimately, you want to track changes for change management, right? from a development standpoint, it's also good for reference. Like I said before, you might not have the same developer over the years. And then we can also take a look at the changes that were made from one version to the next. So when we test software, right, whether it's web or it is native, we need to make sure that it is on isolated environment. It could be a group of system that is in an isolated segment. So if I need to test web application, I need to have it on web application server, right? The application server connecting to the web server and then the domain. So I can simulate that. And virtual machines is perfect for that, right? Or sometimes you can also put it into container via the cloud or the native system and then be able to control it. So it needs to be in a control environment before you deploy because, you know, if you have risk, you're not exposing that risk. So in the part for software assurance, right? At the beginning, it talks about sandboxing, in the isolated that's separate from production systems. So things that are used in operation, that's part of your production system, right? We have to get familiar with these terms if you haven't heard it before. And then when you're using the third-party library, right? We have plenty out there. So that means that if I'm, you know, so for example, I'm writing a program, let's say a Python program, and I'm pulling in, right, import a file, right, like a module, a library that someone else wrote. So basically it's a file, a coding file that someone else wrote. And some libraries are trusted and some are not. So you want to use trusted library. Okay. So for Android, you would see some of those right there. Picasso, Retrofit, Glide, there's a lot of different things. And that's used for a lot of like the interaction on your Android phone or tablet or device, right? So because their library or their code might also create issue for you because it has CVEs. And they document that as well, right? So for number 12, describe the security practices when third-party libraries are used in software development. We want to use trusted third-party libraries. And even that, we want to make sure that we find or identify the common vulnerability and exposure, your CVEs, related to the third-party libraries. Because those things would impose risk to your software. Any questions? We're halfway there. It's a little bit more. And you can find this information on page 10 of your notes. So statistically, it shows, and the text mentioned this, 90% of software development includes some use of third-party code, right? Because why reinventing the wheel? Someone already wrote that program, or I guess some part of that program. So if I'm designing an app and someone already wrote some kind of program for, let's say, you guys seen the endless scroll, right? Someone wrote that already, where you're on social media app, it just keep on scrolling, there's no end. Okay. So why would I need to program it? I mean, write that code if I can just obtain it from a library. So in the next section, it talks about SecDevOps, right? This is very, very popular, and it would show up on exams and certifications. So it's security DevOps, and Dev is for development, Ops is for operation. It's an integration of security in development operations. So that means that it's a marriage between IT, right, and development team. Because in the past, it's usually separated. And you do see that in the culture in some organizations still. So in security, in SecDevOps, we focus on security first. And so we would identify potential risk in development and operation. So when you see this on job listings, right, we would interpret it so you would see the overlapping for security operation, application delivery, and development. We would have more people that's involved in the project. And some of this we can automate for deployment and testing. And that's the key, right? Because even for more people involved, you don't want the slowdown in that. You want to streamline that with a focus. Your objective is going to be producing a secure product. So for 13, it asks you, how should SecDevOps be implemented in organization? We would require involvement of IT and development teams to ensure code security through automated regression testing from development through deployment stages. So testing doesn't occur until your program is written, and then it also happens in deployment stages. Also in the integration right before deployment. And when we test, we would look at security issues or, potential problem in security. So if you want to get into application assessment or risk analysis for application, this is the area that you work in. Any questions? So you can utilize the resources from the notes. I just summarized it a little bit so it fits into one sentence and that try to make sense. So the focus of SecDevOps is to make sure that we have code security, right? And how do we do that? Through testing that can be automated. So here it gives you a graphic for that. Plan, code, build, test, release, deploy, right? Operate and monitor. So for security testing, you would see, a set of tools that you can use. So when we're looking at security issues, we can use interactive application security tool. Or we can use DAST or SAST, dynamic application security testing, or static, right? So dynamic fuzz or fuzzer falls under that. Now, sometimes you would see black box testing, so you don't have any information about the source code. You don't know what it does, right? You just know that it's a source code. So fuzzer would, input various things to stress test the application. Now, static application security testing, which is what we're going to use today, it can be integrated into the IDE, right? Like Visual Studio, things that you use to write and run your code or compile your program. So for 14, it says, how can DevOps ensure, should say no S there, sorry, grammatical error. Ensure the developed code module is trusted. They would need to digitally sign the developed code module. So that's how we would know that it would be trusted. Sorry, let me push this to the next page. And then what is used to detect application code bugs and security issues in CI/CD? That will be your IAST, Interactive Application Security Tool. That's just a type of tool, right? Specific tool might fall under that category. So CI stands for continuous integration and CD stands for continuous development. For dynamic application security testing, your DAST tool that can be used for input vulnerabilities in application, you would use fuzzer. So fuzzing application or fuzzing program would be ideal for this. They're known as fuzzer. And what kind of program is it? It's basically a program that automatically plug in random data into the application to see how the application handles the data. So if the application has a bug, then it's going to report that. So you see all the mobile app or the web app that you would use to log in to pay your bill or fill out financial aid. Those are web apps, right? The feature is what you see. So when I log into my credit card, let's say American Express, the login page, right? One piece of it. But then when I go to a different tab or click different things on the menu, those are additional feature to that particular web app. So based on National Cybersecurity Center, and this is based out of the UK, you can pull this from the notes. The security practices to mitigate attack surface of an application. You need to take a look at the elements of the system or the software and make sure that you have security measure for all of those elements. So for example, right? Remember, let's say that we talked about the web app to pay credit card bill. We have to take a look at how potential attack in all of the features and all of the areas for that particular web app. Can someone SQL inject to obtain username and password or credit card account information and so on? So if we have defensive measure for all of the elements, right, we cover everything. We want to make sure that it is difficult because in security, we're buying time. If the attacker has the resources and time, eventually they can break it down. But if you give them more hurdles, then it is more challenging sometimes that it would deter them from attacking that particular target. So we will need to pen test to determine the level of attack that could happen to our system, right? We want to make sure that disruption is difficult. So we want to make sure that it's resilient to attack like denial of service. So in the case that if we have a spike, right, a huge amount of traffic or requests from that particular source, how are you going to divert the traffic? And so that way we can withstand that type of attack. And then we want to make sure that we detect compromise. So your firewall and your security appliance needs to handle this area. And for the false positive, that's what we want too, right? Rather to be aware than not aware. So going back to infrastructure, which we talked about that last time, and then looking at your IOCs. Indicator of compromises, right? We talked about that last time as well. And the impact of compromise. In the case that they can attack you and if they successfully done so, how can we overcome it with minimal impact? So the more challenges that you provide for you build, right, the security solutions to make sure that your protective measure can withstand a lot of the attack. It's people in the industry, and you hear this all the time. It's not a matter of if it's going to happen, it's going to be a matter of when. So we expect it to happen, but we want to prolong the process, buy time, make it more difficult, and then so that way we can withstand the attack. Questions? And some of you are still typing. I'll give you a minute. We only have 7 more to go, and then we'll take a break and we'll do the lab. I know it's the holiday weekend, so if you need, some of you probably want to head out for a trip earlier. Let me download lab on this one so I can demo. I think I have to re-record my last night lab because I had some modification. So if I have time before I go home today, I'll re-record it. I couldn't log on Zoom on the PC yesterday. Okay. So we'll move to the next part. 18. What reference resources available to identify common web application threats? Whenever you hear web applications, okay, for us in this industry, we always go to OWASP, OWASP, Open Web Application Security Project. It gives you a good set of documentations on the common threats, how to combat the common threats, the type of tools that are used, you know, by those threats and so on. So the resources there. And then they also give you consideration and advice. You okay? Yeah. Did you find the problem? Yeah, they changed the language. Okay. Now, before you release the application, we want to make sure that we look at the standards. So we need to do QA testing, quality assurance testing. Right? Now, some of this, you know, if you go through a vendor to release your app, so let's say that if I own a company and I want to release my app through Google Play or, you know, Apple, what's Apple App Market called? Huh? What's on your iPhone? What is it called? What's the Apple App Market called? App Store. Yeah, because but there's Microsoft App Store. So, but anyway, if you know, before you release it on there, you do have to go through the same set of testing. So, you know, internally you have to do that. And then when you go through a vendor to release your app, you're required to do that. So security and compliance testing. And compliance testing is just to meet regulation, right? Like, for example, you see this all the time, but you probably don't notice it. Like when you fill out your social security number, they cannot ask for the entire, there are some apps that ask for it, but it cannot show in plain text. Normally they just ask for the last 4 digits because it's compliant, right? So there's regulation saying that you cannot, right? You cannot have things stored in plain text for the entire social security number. If it is, it's usually like the last few digits. Okay. And then we want to implement headers and cross-site scripting protections in source code. Right? I went through you know, header stripping or banner grabbing. You would hear a lot of that with pen test class or the ethical hacking class. Because HTTP headers will give you, you know, information. Banner gives you payload information. There's a lot of really cool details that you can grab from headers. So when we implement protection for the headers and cross-site scripting protection for our source code, so that means that the coding component needs to have this particular measure, right? This is why we would see SecDefOps, right? Security incorporated with development. And then we want to implement strict transport security, your HSTS headers, to enforce HTTPS connection regardless, right? So if I type in HTTP and then the URL, it's still gonna load HTTPS no matter what, right? So here are the secure coding standards. So when you go through this, right, I just summarized this. Technical compliance testing, it gives you an example of what that is. So when you go through Microsoft App Store, you gotta go through the certification kit. It is free, so they can use it to test their code. If they pass, then they can publish the app. Okay. I've had students that publish their app on there before. And then you can also do content compliance. So we talked about that before, features and sensitive information, right? And then once you pass, you can release. There's like clickjacking, man in the middle. So all the common attacks that you see with web application, we want to have protection. So the coding for this, sometimes, you can specify it inside the body of that section. It really depends, right? Like if it's cross-site scripting for that particular service, we want to add in a certain attributes. Okay. So when you do static code testing today, you're gonna do strict mode. So you would see, but it's not really, it's not a web app, right? So in code testing, you can also enforce requirement to look for certain things. So Microsoft Web Server uses IIS, right? And then for Linux, you use Apache and other, but Apache is common. So it look like this if you do header grabbing. So the response back from the server would tell us, right? If we have the protection, it would just tell us here, and they use X-ray. So it depends. So Carnegie Mellon has Software Engineering Institute, which is your SEI. And the Cert Secure Coding Initiative is a way that they can standardize the practice in how they would have security in coding. So I harp about this all the time. So when you assess for web application especially, you look for this input validation. That's very, very important. Okay. So for example, if I type in something wrong, right, the form would not take it. So for example, if your phone numbers have a certain amount of digits, you shouldn't have more digits than what it needs because there's potential injection space, right? And then other areas here. So we have to take a look at these when we do assessment. Keep it simple, default deny. So deny is always gonna override allow, always. Sanitize your data. So, and that comes back to input validation as well. So you can put those in for number 20. So according to SEI, what are some of the requirements? We want to validate input, heat compiler warnings, architect and design for security policy. So the rules that we implement needs to be incorporated within the design. Make it simple, deny as default. So some permission control in that area, especially for data fields and access to data fields. Least privilege, right? Because a lot of time in development, they have to have elevated privilege in certain areas to access certain areas. So we need to control that, clean up your data, defense in depth. Quality assurance techniques, we touch a little bit on software assurance earlier. And then standard practice. My charger is loose again. Okay. So on the next question or the next section, it goes over API. And we see API as application program interface. The majority of the time you interface it with as an application. It's an application talking to another application. Right? It's a program using another program. So you see this with vendor, right? Manufacturer, but it can also exist as a service or other things. So the management strategy for API would be that we provision access through automation, because it's system communicating with system or program working with a program. So we would automate that. We would control data access to avoid data leak. And we can also automate deployment, monitor, and make sure that we scale, especially for things like Kubernetes or container API. Because if you don't automate and you rely on someone, and if they're not fast enough when there's a huge demand, what's going to happen is it's going to be out. And when your application is out, right, it's not going to work. So I'm going to give you an example on how API works. So let's go back to Walmart. Let's say that we have a web application, walmart.com, so people can go on there, log in, and buy our product. We have an API for seller that provides Walmart, right? And you see this on Amazon as well. And when people buy products, so let's say I'm a seller, I sell hats to Walmart customer, but through walmart.com. And so as I have other people buying my hats, my API would update walmart.com how much I have in inventory. So if my API is out, my company that sells hats to Walmart customer, right? What's going to happen is you're going to have back order, right? Because there might be someone that buy 10 hats, and on my inventory, it doesn't update. It shows I have 20 hats, but all of them have been sold, right? To other customers, because my API doesn't work effectively. Okay. So you see that in some cases, right, it doesn't scale accordingly, or when it's out, it doesn't work, or when it's out, let's say that it doesn't, when you click on that vendor, it doesn't show anything, right? And you see this on Amazon sometimes, right? It says, uh-oh, right? Something's wrong with the page. So that means that something is not available at that moment in time. They might have an outage or something like that. Okay. So we want to make sure that it's scale automatically and monitor, because if we rely on a human, likely that there's going to be an error. So system to system, we can control the process with automation better. And with the integration for AI, I think that is a lot more effective compared to what we had. Okay, for this one, it's kind of long. You can pull it from the notes, but I'm just going to summarize some of this. We know customer relation management, right? When you call and complain, or when you fill out, things about the company. So that system really managed the customer relationship, track sales leads, and this is the data that feeds into the marketing aspect of the company. So it is essential for CRM, right? You see many corporates, they rely on CRM to pull in new customer or to bring back their existing customer, right? and we can automate the required actions. So for example, you would allow the customer to look at their purchase orders, download their invoices, and then occasionally, you want their feedback, like you can automate the survey. How are we doing? Right? You guys see this all the time. When I called T-Mobile the other day, I asked them 2 questions. As soon as I hung up, I receive a link, right? That's the CRM at work, right? Because they would be like, oh, thank you for being a customer from this year, right? We appreciate your business. We value your feedback. Please do this so we can see how effective we're doing. Then you have enterprise resource planning. This is basically for like account management, reporting, all the things that you need for operation for resources, like sales, human resource. So the other system is tied into ERP. And ERP solutions are very expensive. Same thing with CRM. You see this online, like you would see company like Salesforce or big giant tech company that they have these solutions out of the box and they would sell it to institution like RCCD. Right? Other companies. So if I wanted to buy out of the box so they can customize it and so on. The world that we live in, you see some of this later. I harp about inventory all the time, right? Configuration Management Database, CMDB. This is a repository, a central location where the information for our system and our configuration exists, right? So if you have 50,000 systems in your corporations, in your enterprise, we want to have this information being stored somewhere so that way we don't mess up, right? We have valid data so that way we can reference. And that would be configuration information or items, or it could be hardware like vendor, model, like for example, and then you might have a mix of things in the house too, right? Like you guys sit in here and it's Alienware by Dell. But if you go to Humanities, it's Lenovo, so different time of integration, different brands. And then with that, you have different configuration for different system, different images, right? And so on. So then in the software application that's installed, different departments require different software and so you have variation of things. So therefore we need a database and that will be known as CMDB. And then for content management, your CMS, this is just day-to-day administration enterprise data using a web portal. So why are these things important? Security solutions are required for all of these, right? We have to take a look at their flaws because they are all software or systems. Could be a suite, right? A group of software, or it could also be an actual system integration, like server with application. Now, the next section of the notes, it talks about DNS, and I know that this was covered in 27, 27A, 27B, 41A, and a lot of classes. But domain name system is important. It is used for web, right? You don't have a network without a DNS. So you don't have a domain name without a DNS. So domain name system takes your URL and correlate that with the IP. And we know about the records in DNS could be modified. That is known as DNS poisoning. They can also inject things into the record for forwarding. So I can have all the customer forwarded to a fake server, right? And that fake server could have malware or used to perform phishing. So we want to protect the DNS, and we would implement DNS security or DNSSEC. And what are we really protecting with this particular feature for the DNS or the tool? Is to protect the records that exist in our DNS server. So that, you know, reduce the risk for poisoning. And then lastly, we're going to talk about SOA or service-oriented architecture. So what is it? So if an organization use communication protocol, everybody runs web application, use communication protocol like HTTPS. Okay. But there are other protocols at work. So instead of granularly managing this, we implement what's called the service-oriented architecture, or the industry does, right? This is a service for communication protocol over the network. And it's normally used with enterprise service bus, your ESB. So you can integrate services for a lot of different vendors, right? Because different vendors uses different protocols for communication. So that's what SOA is. So in an enterprise environment, it's definitely a different scale compared to what you would see in a small organization where there are needs for various things. And then with that, we have to support, especially for software application. Okay, so I encourage you to go through the notes, look it over more in detail, right? I try to do the assignments from start to end, so that way we will cover the majority of it, but there are additional details that you can also learn. So look through the notes and go through the questions again. Okay, so after 24, that's it. We would, let me end.